So, hi guys, me, Michael, Carson, and Jimmy are going to be looking at how the ACE2 receptor helps COVID 19 infect and hopefully explain it in a way that will be easy to understand and easy to follow. Terms that are going to be relevant to what we're talking about. The renin angiotensin system, this is the system we're going to be looking at. Basically, it regulates blood flow in the kidneys, liver, lungs, adrenal glands, and arteries. Hypertension is high blood pressure, and we're going to be talking about how that relates to COVID, and it can cause heart disease, heart attack, and stroke, which is the issue with it. And what's going to be regulating this blood pressure is what we call angiotensin, which it has two forms. So 1 and 2 with the Roman numerals, this is what we consider bad angiotensin, as it raises blood pressure, and obviously that increases the risk of hypertension. And then this is converted into angiotensin 1,9 and 1,7, which is good angiotensin in the terms of hypertension because it lowers blood pressure and obviously reduces the risk of hypertension. ACE2 is the protein that does this conversion, and this is what COVID's going to be acting on.
Now you might be asking yourself, well, how is ACE2 related to COVID-19? Well, we actually have that the ACE2 receptor is actually how the SARS-CoV-2 virus gets into the cell. It connects to the protein and then it puts itself in the cell and then reproduces throughout the body. And you might be asking, well, how does that affect the system we just learned about? Well, the COVID-19 blocks the two things that ACE2 does. So we're just left with the rest of the system. And then you might be asking, well, what does that actually matter? What does that actually change? Well, we have our two cells, without COVID-19 and with COVID-19. In the cell without, we have the angiotensin move towards the ACE2 receptor, and then the ACE2 receptor converts it into the good angiotensin, thereby counteracting the effects of the bad and leaving us with an overall neutral or good system. But in the cell with COVID-19, as the angiotensin moves towards the ACE2 receptor, the COVID virus is there. So it cannot change into the good form and only has the bad form, and therefore it gets a really negative system.
So, as you see, there's a lot of science behind this idea of ACE2, but you're probably wondering, how does this really relate to the common knowledge of COVID-19 and kind of, what you already know? So, as you know, there's a wide range of symptoms of COVID-19, from a common cough to a loss of taste and smell, and about everything in between. Furthermore, some infected patients are dying while others are asymptomatic and don't even know they are contagious. You might wonder why this is, and ACE2 receptors may be a possible explanation to this. The more of these receptors someone has may determine how likely someone is to contract the virus and respond to it differently. So, for example, if someone has a high amount of ACE2 receptors, they will be more likely to contract COVID-19. Furthermore, this amount of receptors may also determine the reactions and symptoms someone has from the virus. Different levels of receptors may lead to different symptoms. Given this, ACE inhibitors could prove to be beneficial to stopping the virus. Preliminary testing of these inhibitors has shown decreased all-cause mortality when infected, targeting these receptors and weakening the symptoms.
So here's one example of the comorbid conditions that many people may have and how it is related to COVID-19. Hypertension is associated with increased mortality rates in COVID-19 patients. And why is that? Let me explain it to you. Several animal studies carried out on diet-induced hypertension rat models have established a link between increased blood flow, increased blood pressure, and reduced mRNA expression and protein level of ACE2. Data show that low levels of ACE2 can lead to elevated levels of angiotensin II and consequently hypertension. What are our bodies going to respond to hypertension? The answer is to upregulate ACE2 expression. Animal studies have suggested that ACE inhibitors and angiotensin receptor blockers may upregulate ACE2 expression, and thus increasing the availability of target molecules for SARS-CoV-2. That explains why older people who have comorbid conditions such as hypertension are associated with higher mortality rates. And thank you for your time. I hope you learned a great deal from this presentation.